Hi everybody! On today's show we translate problems that deal with consecutive integers, and we're going to talk about in a second what consecutive integers are. So here's lesson 8. The integers, you've been working with them since about 6th grade. It's our positive and negative whole numbers. So it's our positive whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and our negative whole numbers, negative 1, negative 2, negative 3. So it's our positive numbers and their negatives. It's our positive numbers, 0, and their negatives. Those are the integers. And we're going to be working with consecutive integers. And consecutive integers are numbers that increase by 1. Consecutive means they kind of go in order. So if I'm sitting here at 3, what's the next consecutive integer? Well, who's next in line? 4. Who's next in line after 4? 5. Who's next in line after 5? 6, and then 7. So hopefully you can quickly fill in those 5 remaining blanks there with consecutive integers. So -7, how do I get to the next one? How do I get to the next integer? I add 1, so that becomes -6, and then -5. Well, here's 100. What's the consecutive integer before that? That's 99. Adding 1 gives me 101 and 102. So let's let x be an integer. What if I started at x? How do I get to the next seat? Well, each jump is a +1 relationship. So this becomes x plus 1. That's the next number in line. So if I'm sitting at x, how do I get to the next consecutive integer? I add 1. Well, how do I get to the next one after that? I add 1 again. So I get to x plus 2. Those are our next consecutive integers. So number 1 here says find 3 consecutive integers. Let's stop right there. Do we know what the first one is? No. So let's let x be the first consecutive integer. So who's next in line? X plus 1 is the second consecutive integer. X plus 2, let's go to the next one, is the third consecutive integer. Find 3 consecutive integers such that the sum of the first two is becomes your equal sign. So now I kind of have 2 parts of this equation. The sum of the first two. Well, those are the first 2, and I want their sum. I'm going to add these together. Is 24 more than, so I'm adding 24 to something. I'm adding 24 to what? 3 times the third. So that's the third, and I want 3 times that. 3 times the third, and I want 24 more. So this is a nice linear equation we can solve. Let's combine like terms on the side. I have 2x's plus 1 equals, I'm going to distribute 3x plus 6 plus 24. 2x plus 1 equals 3x plus 30. We're almost there. Subtract 2x. 1 equals x plus 30. And I get -29 equals x. Apparently -29 is x. So if x is -29, what's 1 more than that? -28. Let's go to the next one. Who's next in line? -27. And those are my consecutive integers. Those are my consecutive integers there. The sides of a triangle are consecutive integers. Find the length of the largest side if the perimeter is 12. So the sides of this triangle are consecutive integers. So let's say that's x. Who's next in line? X plus 1, because they're consecutive. Then x plus 2. So the perimeter is 12. Well, the perimeter is the sum of all of these. Let me add them all up. X, 3x plus 3 is 12. 3x equals 9. X equals 3. So notice, what does the question actually want? Find the length of the largest side. The largest side is here, so it's 5. The largest side is 5. The other sides are 3 and 4, but 3, 4, 5, those are consecutive integers. Prove that the sum of three consecutive integers. Well, let's label what we got. X is our first. X plus 1 is our second. And x plus 2 is our third. I want the sum is, so the sum of three consecutive integers. I want to add these up. The sum of these three numbers, if I add three numbers together, is that 3 times the middle? So that's the middle. If I want to multiply it by 3, that's not correct. I need to multiply the whole thing by 3. I want to show that this is true. I want to prove that this is true here. So here's how we're going to do this. Let's start with this side. First of all, let's before we get to the proving it, let's talk about numbers. Prove that the sum of three consecutive integers. If I say, let's go 4, 5, 6. Those are three consecutive integers. Their sum, add them up, gets you 15. Is that 3 times the middle? It is. Let's do 9, 10, 11. Their sum, add them all up, gives you 30. Is that 3 times the middle? It is. So notice that it's just a pattern that always works. If I add up three numbers in a row, the sum is 3 times the middle. And what we're going to do here is prove that. I have x, x plus 1, and x plus 2. I want to show that it's 3 times x plus 1. So let's start with this purple side here, x plus 1 plus x plus 2. What does that equal? I want to show it's that. I don't know it's that yet. Well, if we combine like terms, I get 3x plus 3. What do you notice both of these terms have here? I want to end up here. It looks like a 3 was undistributed. Both of these terms here have a 3. Let's undistribute that. What times 3 is 3x? X. What times 3 is 3? 1. So we showed if I add three numbers together, it's 3 times the middle. We proved that statement here. If you pick any three numbers, you're always going to get the middle one. It's a nifty little number pattern. So we're going to talk about even and odd integers as well. So look at this pattern of consecutive odd integers. So it's not everyone. I only want to work with the odd numbers. So here's 3. The next odd number is 5. The next odd number is 7. Then 9, and then 11. If I want -5, the next odd number is -3, and then -1. I only want to work with consecutive odd integers. So if I'm sitting here at x, pretend that 3 is x, how do you get to the next jump? Well, here's 3. How do I get to 5? Plus 2, plus 2, plus 2, plus 2. Each jump is adding 2. Even with the negatives, I'm still adding 2. So how am I going to get to the next one? Plus 4. So it's important when I work with consecutive odd integers. Notice these. I know that 2 and 4 aren't odd because, look, when you think about odd numbers, I need to skip over the even ones, so I need to add 2. Adding 2 is how I get to the next odd. Luckily, when we work with consecutive evens, 4, 6, 8, -12, -10, -8, it's the same idea. If I start with x, how do I get to the next even number? Well, how do I go from 4 to 6, from 6 to 8? I add 2. How do I go from 6 to 8? I add another 2. So notice, if I'm working with consecutive odds or consecutive evens, it's the same setup. X is your first one, then you have to do jumps of plus 2, because when I work with my integers, I need to skip over the even numbers. I need to skip over the even numbers, so it's a plus 2, plus 2, plus 2 to get to the next one. So let's see if we can translate this equation here. Find two consecutive even integers. I need two consecutive even integers, so we'll let x be the first consecutive even integer, and I'll let x plus 2 be the second consecutive even integer, such that the sum of the larger and twice the smaller is 62. So something is 62. It's the sum. It's the sum of what? The larger, that's the larger, and twice the smaller. X is the smaller one. Apparently is 62. Well, this is straightforward. We can handle this. X and 2x is 3x plus 2 is 62. It's a nice two-step equation to solve. 3 times x is 60. If I divide, I get x equals 20. Notice, what type of number should I be expecting? An even number. 20 is even. Actually answer the question, though. We got to plug it back in. The numbers are 20. What's the next even number? 22. 20 and 22 are the numbers that the sum of the larger and twice the smaller is 62. Find 4 consecutive odd integers. Okay, 4 consecutive odd integers. Here's x. Think of odd numbers. How do I go from 3 to 5? I know it's weird because we're working with odds, but we jump 2. That's the first consecutive odd integer. That's the second consecutive odd integer. That's the third, another jump of 2. That's the third consecutive odd integer. And then I need another 2. That's the fourth consecutive odd integer. Such that the sum of the first 3 is, so there's my equal sign. I want the sum of the first 3. So I'm adding the first 3 together. Is 18 more than, so I'm adding 18 to what? The fourth. The sum of the first 3, I'm adding the first 3 together here, is 18 more than the fourth. That's the fourth. I added 18 to it. So I have 3x's plus 6 is the same as x plus 24. Subtract x, 2x, let me show that there, plus 6 equals 24. If I subtract 6, I end up with 2x equals 18. Dividing by 2, I get x equals 9, which is good because I was expecting an odd number. So let's plug it in. What are my 4 consecutive odd numbers? 9, 11, who's odd next? 13, and 15. If I add these first 3 together, 9, that gives me, so if I add these together, 20, 33, is that 18 more than 15? Is that 15 plus 18? It is, so this checks out. The length and width of a rectangle are consecutive odd integers. So we better stop and have a rectangle to work with. The length and the width are consecutive odds. So if this is x, what's the other side? X plus 2. But think for a second. What's this last side over here? Is it x plus 4? No, because in a rectangle, opposite sides are congruent, so that's also x. And then this is x plus 2. Don't just keep going x plus 2, x plus 4, x plus 6, because it's a rectangle. And in a rectangle, opposite sides are congruent. The perimeter's got to add them all up. So let's run around this rectangle and add it up. 1, 2, 3, 4 x's plus 4 is 152. Find the dimensions of the rectangle. Well, we just have to solve this two-step equation. Subtract 4. X equals 148. And then we need to divide by 4. I'm doing this in my head right now. Actually, no, I'm just going to do a quick little long division over here. 12, 28. I'm getting 37. I'm getting x equals 37. So, what are the dimensions of the rectangle? 37 by 39. 37 by 39. And that gives me a rectangle with consecutive odd sides who has a perimeter of 152. The last one, prove that the sum of 2 consecutive odd integers is always even. Prove that the sum of 2 consecutive odd integers, so I have x is the first consecutive odd integer, and we'll let x plus 2, right, odd I have to skip 1, is the second consecutive odd integers. Their sum, so if I add these together, if I add 2 odd numbers together, 2 consecutive odds, do I always get an even? Is this even? So I have x plus 2. That's 2x plus 2. Is this even? Why is this an even number? Well, let's look at this. 2x is even. If I double a number, when we double an integer, we always get an even number. So this is even. 2x is even. And if I go even and add 2 to it, I'm skipping over the odd and going to the next even. So that plus 2, if I add 2 to an even number, I get an even. If I add 2 to an even number, I get another even. So we showed that if I add 2 consecutive odds, 3 plus 5, that gives me 8, even. 7 plus 9 is 16, even. This is why doubling x and adding 2 always ends up with an even number as well. These prove things are just to get us thinking, but you really need to know how to solve equations and know how to set up your kind of like your let statements over here. You got to know how to set up these problems and really know what consecutive even, consecutive odd, and consecutive integers are to be successful with these problems.